Hello everyone. Here we are saying that the AND gate implementation on FPGA board. So first of all, we should understand what is your AND gate, as everyone know that. So the symbol of AND gate is simple one. It has an AND gate. Let us assume we are having two inputs AND gate. So this is input A, it is input B, and there is the output Y. So you can write the Boolean equation of your AND gate as Y equals to A dot B. So how we can write their programs, because when we are going with that FPGA board, so on FPGA boards you can implement the AND gate using Verilog HDLs. So here we are checking that first of all the hands on Verilog, and after that we will check it how we can implement on FPGA board. So if already the file is exists or the project is open, so you have to go with that new project. So we are having the new projects. Let us assume that we are giving here the name is Verilog project, and you may check that project. You have that project locations. Then go for next. Then click on Artix project, and this is a very important, as we are having that FPGA board, so we have to check that what type of FPGA board we are having, and based on that we will go for selection of your board. So let's check here that, so here we are having the available board is Artix 7. So in Artix 7 you may find here that the Xilinx part number or that the device numbers we are having that. So we are having XC7A35TFT G256-1. So while you are choosing here the boards, we have to check here the family. So what our family is Artix 7. Then package, we are having the package is FTG256, speed -1. So here you find that there are the 5 boards. Out of that, our board is second one. So go for next, finish. So here that new file is created. Now you may find that in design sources there is no file is present. So first of all you have to add the source. So add or create design source, create file, and let us assume we are going for that and_gate. We are designing here that and_gate. Okay, finish. So it has a two inputs, so you can write here that A, B, and Y is output. So in design source the new design file is coming. So that is of your and_gate.v. Open this file and we may write here the program. In Verilog the program is very simple. We are going with that data flow modeling. So that is of your assign simply y equals to, follow your Boolean equation. So in Verilog and is replaced by ampersand. So for AND operation we are using that ampersand. The program is over. Save as. Here you may check their Artix schematic. It's working. So here you may find that the Artix view of AND gate. We are having the input is A, input B, and output is Y. Now here we just skip that simulations. We are directly going for that implementations, but actually before going for that implementations we need to go for simulations. But here we are just trying to go for implementations. So while implementing on FPGA board, this is the FPGA boards that we are having. So while implementing on FPGA boards, we should have the constraint file, and that is of your XDC file or Xilinx constraint files we are having. So click on add source, create here constraint file. You may find here that add or create constraint files. Then go for next, create files. The name should be different than your designing file. So let us assume that add and underscore get underscore xdc. Okay, then finish. So in constant files we have to just write the where actually we are connecting the input and output on your FPGA boards. So here that constant is open, and in it the constant files. As we are having that the board is Artix 7, so which constants files is already available. Now we need for AND gate, we need that 2 inputs and 1 output. So we are having here the switches, sliding switches. So you can consider that the first and second sliding switches are A and B inputs, and there is the LED. So this LED can be considered as an of your output. So here we just choosing this first 2 line as one of your inputs. So I'm just taking here that inputs from this slide 1 switch and slide 2 switch, and just make it copy paste here, as well as I can write here the comments where I can show these are my inputs. So here set property, then package pin. So on FPGA boards it is connected with F4 pin, where gate ports, so this is of your slide switch 0. So actually our input is A, so here I just replace it by A. Then similarly for your G5 pin we are having switch B. So in place of switch B we are having the input is B. And in the same way I am just copying here that LED also, or that output for that means LED for your output. We are using the LED. Here I can write the comments lines as outputs. Then so output will connect with F5 and actual output is Y. So this is simply a 3-line program of XDC file. So just save it, and once it is saved we are going with these steps. So we are having a synthesis, implementations, and program and debug. So if you directly click on generate bitstream file, because on FPGA board, on this FPGA board we have to dump bitstream file. So to generate the bitstream files, so here we are having the bitstream, generate bitstream file options. So I just click on this generate bitstream file, and automatically that the synthesis and implementation process will be open. So you may check here that there is running synthesis design is going on. Once it is done, so this running synthesis is going on. At the same time the implementation is disabled. Once it is done, then that times the implementation will be running on. So you may check here also, it is of your running synthesis in design rules. So we will wait for a few minutes. It is going on. So you may see here. So as implementation is going, it's done. So whether you have to open implemented designs, you may check view reports, then open hardware managers, then generate memory configuration files. Right now we are just closing all these options, and here you find that once that generate bitstream file is done, there is a open hardware manager. So I just click on open hardware manager. So here that hardware is unconnected, so there is a no hardware target is open. So first of all open target, so your hardware will be connect automatically, that means this FPGA board. So here you find on the screen it's going auto connect. as it is auto connect, so we have to program the device. Okay, so program device. So here you may find that bitstream file which is already generated in your own folder. So that is of your Verilog project and it is of your implementation 1, and what my name of file is and_gate.bit. So just do that program and you may check at the same time what will be the output on your FPGA board. So it's doing programming. And here you can find on the board. So this is the AND gate. So for AND gate, 0 and 0, that is 0, then 0 and 1, that is 0, then 1 and 0, that is 0, and 1 and 1, so it's 1. So it works successfully, and here we implement AND gate. Thank you.